As always, the description of the system that we modeled in the videos is provided in the lab document. And also you'll find the assignments for this lab in the lab document, which involves two problems. So in the first problem, what you need to do is to modify your model of the Subway restaurant so that now customers will bulk if there are 4 or more customers in the first 3 stations with a probability of 0.6. So basically what you need to do is to, whenever a new customer arrives, you look at the number of customers in the first 3 stations, the bread, oven, and veggie stations. And if you have 4 or more customers in these 3 stations, that customer will bulk with a probability of 0.6. And then you basically need to evaluate the same performance metrics that we use in the videos. The second problem involves a manufacturing system. So the parameters, different parameters related to the system are given. And specifically, you need to incorporate several logics into this model. First of all, parts that are processed more than once on the grind machine, as you can see, we have this reentrant flow back into the grind machine. So parts that are processed more than once on this station will have a higher priority at the package station. So the queue ranking rule, if you will, for your package station will not be first in, first out anymore. We basically need to prioritize our entities based on whether they have been processed multiple times on the grind machine or not. On the other hand, parts that are routed back to the grind machine more than 3 times are deemed bad and will be scrapped. So you need to implement that logic to get rid of these bad parts. So basically you will develop a Simio model of this manufacturing system, and what we're interested in is the average time in system per part type. So basically we have 2 part types, part A and B, and we want the average time in system for parts A and for parts of type B. We would also like to know the average time in system for all parts, so the overall average time in system. And also we would like to know the percentage of scrapped parts. So you need to define responses for these performance metrics. You also need to verify your models, so similar to what we did in the videos, you can use animation and run your model in the interactive mode, use breakpoints, run in step mode, and other features or other Simio features that we used to verify any new feature that you add to your model. And also you need to compare your simulation results with queuing results. Also, in your model, entities should change colors as they leave each station. And so specifically, I want you to use state assignments for this task. Finally, you need to justify your run configurations. In other words, run length, number of replications, and warm-up period using the S'more plots that you get. So in order to know how to do this, you can refer to the previous labs where we did this. And finally, for those of you that are watching this video lab as part of a course assignment, submission requirements are provided at the end of the lab document. So please make sure that you follow these submission requirements when submitting your homework.